All right, so now on that section 4.3 worksheet, we can try the other direction. So we just went from a different base to decimal. Now let's try and do one where we go from decimal to another base. And let's go ahead and try the octal version, so part B here. So remember with this one, and to just write it down, we're trying to convert the number 1,357. So, taking a look then, there's a couple things again that we have to remember when we're converting to another base, where again, remember, the positions in the system are extremely important. So we have to remember, well, what are the positions in base 8? So we'll write down several here. Remember, we start with the ones position, and then we go up by powers of 8. So it would be 1, and then 8 squared, which is 64. And then we would have 8 cubed, which we can figure out what 8 cubed is, right? 8 cubed is 8 times 8 times 8, which is 512. And then we can do 8 to the power of 4, so we need to multiply. We already did 8 cubed, so we need another 8. So that's 4,096. Now, what we notice when we're thinking about these positions is we're trying to make up the number 1,357, and we need to do it by using these different parts that are all powers of 8. So notice that 4,096 is too big, right? There are no 4,096s in 1,357. So in that position, there would just be a 0. There wouldn't be anything there. So the first position we're going to use is the 8 cubed position. So we're really going to have 4 positions to this number. Now we have to figure out how many 512s fit into 1,357. So we could just try and guess and multiply some 512 by some different things, or we can do it with a division. So if we divide 1,357 by 512, let's pull our calculator back up again. We're going to see we've got 1,357. We need to divide by 512. Notice we get 2 point something. Now remember, all we want is the whole part of that number. So 2 whole times is how many times 512 goes into 1,357. So up here in this position, there's a 2. We need 2 copies of that number. Now we have to figure out how much of the number is left. So from 1,357, we need to take away the amount that we just counted, which was 2 times 512. So we really have 1,357 minus 2 times 512 is 1,024. So again, grab our calculator and clear that guy out. So we've got 1,357 minus 1,024, that was that 2 times 512, and we're left with 333. So now what we're at is, now notice we're asking, well, how many of the second position goes here? So how many 8 squareds or how many 64s? So we're going to take this and divide it by 64. So coming back to our calculator, we'll take that 333 and divide it by 64, and we'll see it goes in 5 times plus some extra. So 5 whole times. So we'll have a 5 in that position. Then again, we've now counted 5 copies of 64. So from the 333, we need to subtract 5 copies of 64. So 333 minus, let's see, 5 times 64 is 320. So we're going to have a 13 left over. And now we're on to our 8th position. So we don't even need the calculator for this one. We can just see that 13 divided by 8, well, 8 only goes into 13 once. So I need 1 copy of 8. And then I'm going to take that 13, subtract that 8 we just did, and we're left with 5, which, well, how many times does 1 go into 5? It goes in 5 times. So all in all, we end up with the number 2515 base 8 as our final answer. Now, a great idea to do with these problems is to check your answer, because we know how to convert this number, 2515 base 8, into decimal. So in order to check our answer, we just have to try and go the other way. So we should end up with this as being 2 times 8 cubed plus 5 times 8 squared plus 1 times 8 plus 5 times 1. Because we have a 5 in the ones position, a 1 in the eighths position, a 5 in 8 squared, and a 2 in 8 cubed. So this is 2 times 512 plus 5 times 64 plus 1 times 8 plus 5 times 1. So figuring some of those out, right, 2 times 512, we already knew was 10,024. 5 times 64, notice over here, we actually already did that. 5 times 64, we also already had done the 2 times 512. If you want to redo it, just to make sure that you did your math okay, we can, but we should then have plus 320, and then plus 8, and plus 5. So 1024 plus 320 plus 8 plus 5 indeed gives us our 1,357. So our answer does indeed check out, right? This was all just doing a nice check of our work. So our final answer is 2515 base 8, where we had to figure out how many in each of the positions in base 8 we needed.